Hi, today we are going to be looking at metrology and how it is applied in pharmaceutical calculations. Metrology is the study of measurements, and it's important that we apply the proper practice when it comes down to measuring and weighing substances, when it comes down to compounding or pharmaceutical practice in general. So the objectives for this lesson are, we're going to explain a couple of terms such as error, percentage error, least weight, quantity, etc. We're going to learn how to calculate error. We also are going to do calculations as it relates to sensitivity requirements, how to calculate least weighable quantity, least measurable quantity. And we're going to apply all of these concepts now to demonstrate by way of calculations how to use the aliquot method or the least weighable method to weigh or measure quantities that are less than the least weighable quantity or the least measurable quantity. Just to recap certain concepts that we would have covered already in previous lectures. The accuracy and precision are two measures of observational error. So accuracy is how close or how far off a given set of measurements are to the true value, while precision speaks to how close or dispersed those measurements are to each other. Okay? And of course you know this already. This is just revision for you. Error. What is error? Error is the difference between the measured value and the actual value. So for example, if 3.2 kilograms of a given substance is to be weighed, but the actual weight is 10 kilograms, then the error is going to be 6.8 kilograms. Percentage error, on the other hand, is the measured value minus the true value, divided by the true value multiplied by 100%. So if we were to determine the percentage error for the weighing that we did here, it would be 6.8 times 100% divided by 3.2, and that will give you an error of 212.5%. Now, based on our previous lectures, we know that that is grossly inadequate and unacceptable, because acceptable error in terms of pharmaceutical calculations and compounding would be between 5 and 10%. Let's look at some more terms. Sensitivity requirement. Sensitivity requirement really is the amount of load that one is going to expect to see moving the so the sensitivity requirement is the amount of load that it takes a balance for the pointer of that balance to shift from one graduation to the other. So just as you are putting on something on a scale in your kitchen, the amount of load that is going to cause that scale to move from that pointer to move from one graduation to the other is what is called the sensitivity requirement. That's the required load that causes that to happen. And it's very important that we know the sensitivity requirement because it is used in determining the percentage error as seen here. So this is the equation for sensitivity requirement. Sensitivity requirement designated as SR divided by the quantity desired times 100% is going to give you the percentage error. An error that is associated with weighing of plus or minus 5% is acceptable. So for example, what is the sensitivity requirement of a balance? the potential error is 5%, and the least weighable amount that can be weighed is 120 milligrams. Of course, we're just going to be putting that into the equation and substituting for the quantity desired, which is 120, and the error, which is 5%, and solving for SR. And the SR that we would have gotten is 6 milligrams. This means that it takes a load of 6 milligrams to move that pointer of that scale from one graduation to the next. Now, when we're talking about least weighable quantity, the equation that is used is sensitivity requirement divided by the percentage acceptable error times 100%. Now, if we are to determine the least weighable quantity, we would definitely need the sensitivity requirement and the percentage error, as seen here. Now, the error is not given, but the accuracy, the level of accuracy of 95% is given. So it means then that the error is 5%. So, putting that into the equation, we would get 130 milligrams. So, just simply arranging the terms in the equation can give you the least weighable quantity, the percentage or the acceptable error, and the sensitivity requirement. So the sensitivity requirement would be 6 milligrams. Yes, the sensitivity requirement would be 6 milligrams if our least weighable quantity is 120. When you compare that to sensitivity requirement of 6.5 milligrams, which results in the least weighable quantity being 130 milligrams. It's just a matter of putting the different terms in the formula. Least measurable quantity, of course, is going to be dependent on the capacity of the measuring device. And generally speaking, the least measurable quantity of measuring vessels are determined by 20% of the capacity of the measuring vessel. So, for example, I want to find what is the least measurable quantity that a measuring cylinder can measure, a 25 measuring cylinder. You find 20% of the capacity of the measuring cylinder, and that would be 20 over 100 times 25, which gives you 5 mils. What does this mean? It means that an acceptable error is associated with measuring at least 5 mils in this measuring cylinder. The error progressively increases if you should measure volumes less than 5 mils. So we tend to use this rule when we're doing pharmaceutical compounding, that 20% of the capacity of the measuring device is what is our least measurable quantity. If the degree of precision in measurement is beyond the capacity of the measuring instrument, one can achieve accuracy by calculating and measuring in terms of adequate parts. This means we weigh or measure an amount that is more than what is required and use that to make a concentrated mixture by diluting with a solvent. From this concentrated mixture, a fraction is removed that would contain the amount required that can be weighed or measured within the capacity of the instrument with acceptable precision. And there are 3 methods that can be used or employed to weigh or measure small quantities that are less than the least measurable or the least weighable quantity of our instrument. These are the aliquot method, the least weighable / measurable method, or serial dilution. We will be looking at the first 2, aliquot method and least measurable method, in this recording. So, An aliquot is a fraction or portion or part of a mixture, and this mixture will contain a multiple or submultiple of the ingredient required to be weighed or measured. In this method, a larger than needed portion of the substance is weighed. It is then diluted with an inert material, whether it be water, lactose, or starch. An aliquot of the resultant mixture that contains the required quantity needed is then weighed with desired accuracy and precision.